now. Okay, this is what happens. I'm being stubborn. I'm being a stubborn old mule. Okay, so we know they all have the same voltage. So power equals voltage times current. Voltage equals current times resistance. So P equals V times I, and V equals I times R. Okay, so far we're doing good. That part is true. Okay. And like I said, right now we have too many unknowns. Our unknowns are X, R, Y, and I and V. So that means we have 4 unknowns. And so if you have 4 unknowns, you have to have 4 equations. And so I don't know why. I'm gonna give these some numbers because I just don't like that. I probably forgot to write down something when I copied this problem. So we're just gonna make it up. So we're gonna assume that this resistor is 5 ohms and this resistor is 20 ohms, okay? So then the resistance seen by that power supply would be 5 ohms in parallel with 20 ohms. That's the product over the sum, 5 times 20 over 5 plus 20, and that's 4 ohms. So now that means I can rewrite this as a power supply with 70 watts and some voltage, and that's a resistor that has 4 ohms. So power equals voltage times current, but power also equals I squared R. And so what we're looking for is the current right here, I. So I have 70 equals I squared times 4 because the resistance is 4. R is equal to 4. So that means I squared equals 70 divided by 4, or the current is going to equal to the square root of 70 over 4. All right, I'm feeling a little bit better, Steph. I'm feeling a little bit better. I feel my help coming on. I feel my help coming on. All right, square root of 70 divided by 4. So hold on. 70 divided by 4. I think you're now starting to see why I don't go live a lot. See how much we having to work over here? 4.18 amps. 4.18. So the current is 4.18 amps. 4.18 amps. That's the square root of 70 divided by 4. Okay, let me open the calc back up and make sure I didn't mess it up. 70 divided by 4. And then I took the square root of that. Hold on. 70 divided by 4. 70 divided by 4. And that's 17.5. And then the square root of 17.5. 17.5. Two lives in 2 days, Steph. You are blessed to see my face. 2 lives in 2 days. All right, 4.18 amps. All right, so that means that the voltage over here, which is I times R, is going to be 4.18 times 4. So that's going to be 16.72 volts. All right, so that means everything up here has a voltage of 16.72 volts. So that means that the current through that RX lamp should be 16.72 divided by 5. And the current through that RY lamp is going to be 16.72 divided by 20, okay? 16.72 divided by 5 is 3.34 amps. Okay, and 16.72 divided by 20, we are absolutely blessed and highly favored all day long. 16.72 divided by 20, I feel my help coming on, I feel my help coming on. 16.72 divided by 20. All right, we're getting good answers now. That's 0.836 amps. All right, so now what I was saying is that the way that we check that this works is called Kirchhoff's current law. Kirchhoff's current law says that the current into a node equals the current out of a node. So when I come in here right now, and I'm gonna put some values on here, if the current right here is 4.18 amps, this is called a node. A node is the meeting point of elements. So that's a node. Then down here is the ground, and that's called a node. So that means the current down through here and the current down through here have to add to 4.18. This is how I knew that problem we just deleted, something was wrong because it wasn't adding up and I didn't want to figure out why, so I just started over. So what you're going to see here is that 4.18, the current coming into that top node has to equal 3.34 plus 0.836, and it does. So we now have a happy problem. Voila! All right.